Hello everyone, my name is Jade, and today I'm going to share our study, trade-offs between defense and competition in gregarious juvenile fluted giant clams, Tridacna squamosa, this species. And this paper was accepted and published by Marine Biology this year. First, gregariousness is defined as the tendency of an animal to aggregate with the same species, and is often associated with the benefits like reduced predation risk and increased reproductive success. However, it also has several costs like increased transmission of parasites and pathogens and increased detection risk by the predators. However, the major cost is the competition for the result within the same species. For example, some of fish will form large schools for protection from their predators, but they tend to separate into smaller groups after the predator leaves. And also in magic crabs, they aggregate only for protection when they are mating or molting, which means changing their exoskeleton, and after that they disperse. Similarly, aggregative behavior in sessile marine animals is common, especially within Bivalvia. As mentioned before, aggregation may bring some benefits such as exclude interspecific competitors and increase reproductive success. However, these sessile marine animals encounter the greater intensity of negative effects because they can move. So compared to the motile animals, they may suffer from shell deformation and it reduces growth rate. While not as well studied as mussels or oysters, giant clams can also display gregarious behavior. You can see there are so many giant clams clumped together. In previous study, giant clams in wild population and in the laboratory condition or in aquaculture facilities, scientists found that they have some aggregation behavior. So let's think for Tridacna squamosa, aggregation is a natural behavior. And in Monroe study, how close to the same species is important for giant clams to spawning at the same time. And moreover, unlike other bivalves, giant clams are known for their ability to photosynthesis through symbiotic zooxanthellae living in their tissue. So it may have additional meanings for the benefits or the cost in aggregation behavior. With several disadvantages, gregariousness in Tridacna seems to be a risky strategy, but its adaptive significance hasn't been examined yet. So in this study, we use manipulative experiments to test these following hypotheses. First, giant clam growth is negatively affected by aggregation, and aggregated giant clams are more susceptible to ectoparasites, which means they would attract the parasite easily. And third, aggregation provides individual giant clams with greater protection against crushing predators like the crab. And in our experiment, we used 72 juvenile giant clams to test the effect of aggregation on the growth rate and ectoparasite load. And we dispersed these 72 juvenile giant clams into two groups. One is dispersed and the other one is aggregated. Especially to mention, these giant clams had been already infected by the parasites. Tridacna comingi is a common ectoparasite snail in cultural giant clams. And before the experiments, these clams were cleaned and brushed to move all the parasites at the first. And second, the clam shell were cleaned every 2 weeks. And after 112 days, shell length and ectoparasite snail count were measured, with randomly chosen giant clams in 2 groups. And in another test, we used stone crab, male manicure hardwicked, as a predator because this species is known to prey on bivalves and has consumed giant clams in live condition. All of the experiments were conducted after dusk because this kind of crab mostly active at night. And before the trials, the crabs were starved for 1 week. Then predator-prey interaction were recorded with infrared camera, and we defined the successfully predation for crab of its handling time is from the moment the crab grabs onto a plate to the moment of dislodgement or breaking. You can see it take away or it break this giant clam. And after conducting the experiment, we use statistical analysis to get our result. In growth experiment, we compare the mean shell length and mean percent growth in shell length, and we find those giant clams reared in dispersed treatment has a larger and greater mean shell length and growth rate than the other in the aggregated ones. And in the other hand, the giant clams in aggregated situation has more ectoparasites than this in the dispersed one. So we suggest that, anyway. Sorry. And in another test, we find it takes predators more time to handle aggregated shell. You can see mean handling time for crab to handle an aggregated giant clam is very 167 seconds. Then it's larger than 87 seconds. And it has to be mentioned that there's no significant difference in mean search time between 2 treatments. And interestingly, crab were observed to switch prey more frequently in aggregated treatment. Now I'm going to talk about discussion. The observed depression of growth in juvenile giant clam is not unexpected, as this phenomenon has been documented in other good-living bivalves such as oysters because of space constraints and food competition. However, the effect on the growth in giant clam were greater than in mussels. So we suggest that the dependence on symbiotic zooxanthellae for photosynthesis is important for Tridacna. However, in aggregation, space constraint can prevent some clams from opening fully, and the shell constriction and mental shedding will have a greater negative effect. So it will lead to reduce photosynthetic output and hence the growth rate. And with our result, the difference in parasite abundance is probably not caused by our maybe efficient cleaning or overlooking during the regular control experiments, because the difference was very large. So we suggest that it's a consequence of reduced distance between the hosts in aggregation. Then, protection from predation remains one of the most important drivers of gregarious behavior in animals. Our findings suggest that aggregation in juvenile giant clam can protect them from crab predators. That is, the compactness of aggregated clams obstruct the movement of the crab, and moreover, the defensive skills on the valves, you can see this, will fill the gap between the clams in aggregation situation, so further increase the handling difficulty for the predators. Finally, we demonstrate the trade-offs of aggregation in juvenile Tridacna squamosa for the first time, and our hypothesis were testified through experiments, which indicate that the gross cost of aggregation are likely a necessary trade-off to ensure survival during juvenile phase. Last but not least, while aggregation brings benefits for this species, the effect is expected to last only for a short time. So that's my presentation. Thank you.
All right, so 30 seconds left. Good time control. So Q&A now. How to pronounce? Penis? How to pronounce your English name? Kinnes. Kinnes. How to pronounce? How to read? Ken. Alright? So, Ken. Second, Austin. Third, Henry. Fourth, Irene. Fifth, Ryan. Okay, starting with Ken.
Identify your result to prove your hypothesis.
Which I have 3 experiments, so which one?
What is his question? Repeat his question.
He said, what is the result with my experiment
To prove your hypothesis.
to prove my
You
hypothesis?
have 3 hypotheses.
Yes.
Right? Yeah, but you prove let's talk all hypotheses are proved.
Yes.
But I don't understand how your result can connect to you prove your hypothesis.
I see. First, my hypothesis 1 is dragon clam growth is negatively affected by aggregation, and connected with my result. You remember the mean shell length and mean percent growth in shell length. All the dragon clams dispersed has a greater mean shell length and growth rate than the aggregated one. So my hypothesis 1 is clear. Okay, and the second is aggregated one are more susceptible to ectoparasites, which means they would attract more parasites. Okay, and you can see the result here. It's a frequency of infestation, which means I have 24 dispersed giant clams and 8 has ectoparasites. However, in aggregated one, 23 out of 27 have ectoparasites. So the hypothesis second is testified. And in the third one, aggregation gives individual giant clams greater protection against the crab. And you can see the handling mean time. The aggregated one will have more time and need more time to go by the crabs. So is this clear? Okay, thank you.
Next, Austin.
At the first page, what's the lost line arrow mean?
You mean this L?
Yeah.
Because this species is named by Lamarck. You know the scientist Lamarck. He set up a hypothesis that if you don't use your neck and if you still use your neck all the time, and your neck will be longer. Okay.
Next, Henry.
How long the return
In the day.
in the day? What time?
What day? I don't understand what you are asking.
Next day. How long?
How long is the experiment? In the growth rate and ectoparasite load, we conducted experiment for 112 days. Yes. And in other, I know. I actually forgot for other than and over than a month.
Well, Irene.
What's the else benefits to except for and protection from predator for the aggregate?
You mean what else benefits for aggregation?
Except for
Protection from predation. I think in some biomass situation that they aggregated not only for predation and protection from the predation, but for increase their reproductive success because they can move, they cannot move, so they need. Imagine if you need to stay at a place one day, and when you need to reproduce, you need someone closer to you, not maybe 500 meters away, and you can have the chance to mating with him. So I think increase the reproductive success is one of the most important reason to aggregate.
Ryan.
You say the joint plan can move, and I'm very confused about.
You are confused about how giant can move, right?
Can or cannot?
Cannot. Okay. I think it can.
Can move or cannot?
Can.
Can't. You say cannot. Can't. Right? Okay, he said cannot.
Yes, giant can move. I'll show you some pictures. You can see. I don't know if it's too light. And there's a structure called viscous under the giant plan's bottom. Here's the top one. Here's the top, and here's the bottom. Here's a structure called viscous, and it will stick out its bristles to reach somewhere like maybe originally it's here, and it will stick out its bristles to attack another place and move along, move to it. So it can move actually. Yes.
One volunteer question. What's your name?
CK.
Sorry?
CK.
CK, okay, CK.
Can you tell me, in your presentation, you say you have they have two groups, right?
Yes.
Can you show the wait. Here, yes. And when I go to them, I always see the group is, they always is alone, and alone. And can you tell me where I can see that group in the waters?
With previous studies, they said this actually aggregation is infrequently seen in wild environment. So I cannot assure you one day when you go scuba diving and you will see nine Tridacna squamosa aggregate together. So it's infrequently, but in our research, we want to know why will they aggregate. Yes. Thank you.
Okay, my turn. Okay, so first of all, you can see that she has very open, very informative headers. So her headers are always some conclusions that or the key message that she wanted to deliver. And her presentation, like the previous one, is also image rich. And her pronunciation is, of course, very clear. And sometimes we use this kind, for example, like this slides, like this, arrows, to show the general message, like a increase or decrease. That would be better than text. Okay. And she has a very clear, objective slides. I don't see where. Sorry, to mention. There was a very clear, objective slide. So she knows her. She presented the hypothesis, and then this is accompanied by a very nice conclusion slide where she has this. What is that? 18. Okay. So she has this check. So it's like a work done. Things are done, completed, which is good. Okay. So yeah, I think overall it's a good talk. And then of course I will have some criticism. The first is I think at the discussion you look at the script very often. So I would say that this is probably because this is not familiar enough, and I'm sure you will be able to improve next time. And so it will be great to look at the audience more often next time. And I think yeah, the talk was already full, but maybe at some point you can explain. I'm not sure if all of them understand text like what is ectoparasites or spawning, text words like that. Okay. And then regarding the presentation results, this is, as she has shown, this is actually the original figure in the paper. And you choose to present tables. So, but in general, we would say figures are better than tables. Okay. So it would be actually good to change. Although the tables are nicely made, it would still be better because human eyes are more sensitive to this than numbers. Okay. And then I will echo one of the comments that would be the connection of your arguments to data, because you choose to present all the data all together and then present results and present your interpretation on how they are linked to hypothesis testing. But it will be actually, for a short talk like this, it will be good to throw out your argument directly right after the data, so that everybody know, okay, this data links to this conclusion. All right. And then at some point, you have very, very long slides, very, very long lines. I think it's here. Yes. Yeah, you are like a blah, 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 without any text following any of the text here. So I was waiting. Okay, finally you say something related to this. So if you have super long line, it will be always good to throw out at least some keywords, so everybody can follow what you are really talking about. All right. So now, I'm going to talk about one advanced skill. That would be because this story itself is very it's a little bit like a daily life. So I would say you can sort of humanize your research objects. For example, you mentioned several places like gregariousness or starve for 1 week. That's poor guy. And then you say switch prey. I think these can all be humanized so that your talk will be more interesting. Okay. So, but overall it's a very nice talk. So let's thank Jade.